We're going to start with a parent function quiz. So the sub can pass out your half sheet of paper parent function quizzes, and then once everyone's done, remember when you're done, please turn it over so the sub knows everyone's done. Then once everyone's completed, pass out the red pens so we can grade them, and then restart the video. So at this point, pause the video and take the quiz. All right, now that you have finished the parent function quiz, make sure everyone has a red pen, and let's pass them to the person that is in front of you today, and write your name in the bottom right-hand corner, and let's go over the answers here. First one, x cubed plus 1. Change my pen here. So x cubed plus 1 is a cubic equation that's moved up 1, so it goes through that point right there, comes up like that. Give them 1 point for moving it up 1, 1 point for the shape, and 1 point for going the right way. Total of 3 points, remember, for each one of these. You take a look at that. All right, negative square root of x plus 2. Moves it up 2. We move it to the negative in front of the square root, flips it over the x-axis, so it's going to go down. We move it up 2. It'll look something like that. Once again, 1 point for moving it up 2, 1 point for the right shape, 1 point for flipping it over the x-axis. 3, absolute value of x minus 2 plus 1. So we're going to move it to the right 2. We're going to move it up 1. The negative in front flips it over. So we get our upside down v like this. 1 point if it's upside down, 1 point if it's right 2, 1 point if it's up 1. If any of these you are unsure of, if you're not sure how to graph, just circle it, leave it blank, and then when we go to hand these in the final time tomorrow, I can answer any questions. So just do the best you can. Circle it if you're not sure. X minus 2 quantity squared plus 1. I'm going to move it to the right 2, up 1. And then we have a parabola that looks something like that. To the right 2 is a point, up 1's a point, and the right shape's a point. So at the top, put how many they got right, and then hand it back. Tomorrow we'll take one more of these parent function quizzes, and we'll also take a regular quiz tomorrow just to remind you, and then that'll give you a chance to hand in whatever one you did the best on. All right. We want to talk about inverse functions today, so I will first pause here for a minute and let the sub pass out the inverse function notes. All right, we want to start off by talking about inverse functions, and we want to talk about how to find inverse functions, how to recognize inverse functions. But first, let's just kind of talk about it informal, kind of understand what they mean. So, if I have a function x plus 2, its inverse function would be x minus 2. It's kind of like the opposite. Now let's show what happens here as we put numbers in. If I put negative 2 into my function f, I get 0. If I put negative 1 in, I get 1. If I put 0 in, I get 2. If I put 1 in, I get 3. If I put 2 in, I get 4. Now in the inverse function, let's see what happens. If I put negative 1 in, I get negative 3. 0, negative 2. 1, negative 1. 2, 0. 3, 1. Now, what I want you to do is compare the function and the inverse. The function has the point -2, 0. The inverse has the point 0, -2. Let's graph that. So my function, I will graph my function in red. I'll graph my inverse in blue. My inverse has the point 0, -2. My function has the point -2, 0. My function has the point -1, 1. My inverse is the point 1, -1. I have the point 2, 0. And I have the point 0, 2. And if you see, I have the x plus 2 is this line. X minus 2 is this line. Now these are both straight lines, so it's going to be hard to see that. But what happens is the x's and y's get switched. My x's over here become my y's over here. My y's over here become my x's over here. See, 1x, 3y becomes 3x, 1y. Now, if we look at the graph, really what we're doing is we are flipping our graph across this line. If I took this line, y equals x, switch the x's and y's, wherever a dot is above that, it now goes below that. So really we're just switching those x's and y's. That's the big key to the inverse, switching x's and y's. So let's look at an example. If I have a function that has the point 2, 4 on it, and has the point 4, 7, which is up here somewhere, what would the inverse value of 7 be? It switches the x's and y's. So if I have 4, 7 for f, the inverse function would be 4. The x's and y's get switched. So here is the point 4, 7. My inverse would have the point 7, 4. This is the point 2, 4. My inverse would have the point 4, 2. So what's the inverse of 4? 2. Now if we double these up, f of f inverse of 4 is 2. We did that just above. And what's f of 2? 4. They cancel each other out. You reverse it once, you reverse it again. You're right back where you started. So f of 4 is 7. What's f inverse of 7? I did that up here. Is 4. So you can see a function and its inverse just cancel each other out. They're just the opposites. What if we had f of 1 is 5? And f of -2 is 5. Sorry. Put that in the wrong spot. -2 is 5. If I wanted to find f inverse of 5, what's the answer? Is it 1 or is it -2? Because we have that question, this doesn't have an inverse. And the reason is we want to introduce this idea of 1 to 1. A function is 1 to 1 where every x is paired with exactly one y. Is paired with a unique y, and every y is paired with a unique x. So if you go back here, 5, that's the y coordinate, is paired with both -2 and with 1. Y is paired with two x's. Y can only be paired with 1x. So this is not 1-to-1. In order to find an inverse, we have to have 1-to-1. The inverse of a function, you have an inverse only if your function's 1-to-1. And the way we talk about that, we talk about 1-to-1. Easiest way to see that is a horizontal line test. So if you have a graph that doesn't pass a horizontal line test, intersects 2 points at the same spot, not 1-to-1. Okay. So here's our formal definition then. Let's actually get to some formal stuff. A function f is 1-to-1 with the domain D and the range R, then the inverse denoted f to negative 1, only if these are true. Now some of these are kind of, parts of this are in your notes. This is what we already did. If f inverse of b equals a, then f of a equals b. X's and y's get switched. We also did this, which says if you take the composition, put one inside the other, they always cancel out and you get x. Let me go back and just show you. Here is what I'm talking about. F inverse of 7 is 4. F of 4 is 7. That's that AB one. If we go back here, oh, we're on the same page. Here is the other one, how they work out and give you just 4. So 2 different ways we can define an inverse. So let's show these are inverses. To show this is an inverse, we want to show that f of g of x equals just x. So I'm going to put g into f. And hopefully everything cancels. So I put g in place of x. The 3's cancel. I get x plus 1 minus 1. The 1's cancel. And I get x. So yes, they are inverses. You don't have to put it in both ways. Pick one, put it in, that's good enough. So how do we find our inverses? We have 3 steps. Our first step is to check it's 1-to-1. So let's go through our steps here. F of x equals 3x minus 1. Check. Is it 1-to-1? Well, that's just a straight line. Slope's 3, y-intercept. So yes, that's 1-to-1. 2, switch our x's and y's. Now there's no y here, but we all know that f of x is kind of like a y. So we'll switch our x's and y's and get x equals 3y minus 1. And the third step, this is the hardest one, solve for y. So I solve for y. I add 1 to both sides. Divide both sides by 3. And I get x plus 1 is 3. So my inverse, x plus 1. So our 3 steps. Check if it's 1-to-1. Does it pass the horizontal line test? If you're unsure, graph it. But 1-to-1 is the horizontal line test. 2, switch your x's and y's. 3, solve for y. Step 3 can be the killer. Many times, that's the hardest one. So another example. X plus 1 over x. Now, first off, I'm just going to kind of give it domain and range. We've done domain before. X cannot be. What number makes the bottom 0? 0. The range we haven't talked about too much. I will just tell you the range can't be 1. So first step, is this 1 to 1? Yes or no? If you graph it, let me graph it here. We have x plus 1 divide by x. Passes the vertical line test. Now, it doesn't necessarily look like it easily, but right here, you can see a horizontal line never intersects two parts of the graph. Okay, so our graph's 1 to 1. So we start off, yes. 2, switch our x's and y's. So we basically just switch wherever we see an x, rewrite a y. Now we need to solve for y. Oops, I'm sorry. Should be a y down there. Now to solve this, what I'm going to do is cross multiply. Think of this as x over 1. Cross multiply. So I get x times y. 1 times y plus 1. Now remember, we're trying to solve for y. We want to end up with y equals. So for real quick, if we have a simple equation and you want to solve it, what do? You get all the x's on the same side and you get all the numbers on the other side. Well, that's what we're going to do. We're solving for y, so we're going to get all the y's on the same side. All our numbers on the other side. Now, here's the hardest step. If you could understand this step, you're going to be in great shape. At this point, what we have to do is both terms have a y, so I need to factor out the y. That's the hardest part right there, is seeing how I took a y out of here to get 1. I took a y out of here to get just x. And then finally, I divide by that x minus 1, so I get y equals 1 over x minus 1. This step here is the killer. To see, I have to factor out the y. So what is my inverse function then? My inverse function is 1 over x minus 1. So my steps, 1 to 1, check. Switch x's and y's, check. Solve for y, check. Now let me show you something kind of interesting here. If I look at my new inverse, I look at my domain and range. The bottom, x minus 1, my domain x cannot be 1. I'll tell you, the range cannot be 0. We won't worry about the range, I'm just showing here. But notice what happens. Can't be 0 over here, becomes my range over here. I switched the x's and the y's. My range over here can't be 1, becomes my domain. I switched my x's and y's. You try this one. I'm going to give you a minute here to see if you can set this up and solve it. I'll tell you right now the domain is x cannot be 3. My range, y cannot be 0. I'll give you a second to try that. See, do your 3 steps. I'll tell you step 1 right now so you don't even have to grab it, is yes, it is 1 to 1. You try to do step 2. In your notes there, do step 2. Switch the x's and y's. Step 3, solve for y. I'll give you a minute to try that. Go. All right, I've switched the x's and y's. X equals 2 divided by y minus 3. Now I need to cross multiply, so I have x times y minus 3 equals 2. Now remember, I'm trying to solve for y. So I'm going to distribute this through. I get xy minus 3x is 2. I'm solving for y, so I want y on the side by itself. Move everything else to the other side. And finally, divide by x. So my inverse is 3x plus 2 over x. Once again, domain and range get switched. My domain, next there, sorry, I wrote that down wrong. Threw me there for a second. This should not be a 2. This should be an x. So x does not equal 0. Y does not equal 3. Now I'll just say this here. X squared. We know x squared. It's a parent function. So if we think about, it's a bad graph. We think about x squared. It doesn't pass over the line test. So if we're doing our steps, we can know we're done. We stop. Don't go move on. However, there is a way we can find the inverse of this by doing some more work. I'm not going to worry about that. You don't need it for your homework right now. So we'll talk about that later when I come back. We will need it later in trig and some other stuff going forward, but we don't need it right now. All right, homework. At this point, the sub can pass out the worksheet for the homework for inverse trig functions. Depending on time here, I have another video after this one on parametric equations. So if you finish this homework and there is time for another video, we can watch an additional video and have an additional homework based on the time. But at this point, you can get started on inverse functions.